welcome back everyone to the Hello World Guide. This is another episode of the Android game development series, and in this video we are going to actually start making our game, which is going to be Breakout. So first of all, to allow some more customization, we are going to add a vector 4 for a background color in our render data so that we can specify a background color. And since alpha does not really mean anything for a background color, we are going to make it a vec3. Now in render.cpp, before calling glclear, we are going to call glclear color and give it all of the components of our background color that we receive from the draw data, and give one for the the alpha value. And with that we can use our background color. We can set this to any value we like and we should get the same colored background. For example, I'm going to set this color, for example, to like a light blue or a sky blue color. So we can go ahead and just specify the components of the vec4 here. For example, we can, for red, I'm going to say 0.7 here. And similarly, we are going to say, for example, 0.7 for the green as well, and 1 for the blue. Actually, let's change the green to 0.8 to give it more of a tint, and then 6.5 for the red. Now, if I go ahead and actually run that, you can see that we get the blue color that we wanted in our background, and that is working perfectly. Of course, our movement still works as well. So yeah, that gets that done, and now we can get started with figuring out a way to organize our game. So there are multiple ways to go about this. For example, we could try to use a traditional object-oriented approach with inheritance, but we are going to make a simpler approach here, and since our game is pretty simple, we are going to just create a struct called GameObject. I'm making this a struct because this is not going to have too many functionality. It's not going to be a virtual class, just having some basic things like position and size. And we could add a rotation as well, but since most objects are not going to rotate in our Breakout game, so we are not going to add that. So we are going to add a texture pointer as well to the game object, because of course it's going to be drawn. And now we can go under game.cpp and we are going to change some things here. So inside of our game.h, I'm going to remove all of this unnecessary stuff that we added for testing, and we are going to add a vector of game objects here for that I'm going to just call objects. So now going under game.cpp, well, actually let's first add a vec for color for the game object as well, because we want to apply color to objects. So with that, we can go under game.cpp now, and we can remove all of the unnecessary code that we have got here. We are going to remove this as well, and we are going to remove all of our touch event handling as well, because this was just for testing. So now we can remove all of this until we actually want to do something useful with this. So yeah, with that you can see that we have got this. I'm not going to remove that because we still do need the conversion. Anyways, I'm going to remove the text commands here, and actually we are going to remove these draw commands hard-coded as well. Instead, we are going to use pushback to add the draw commands for each object. So we are going to loop over each objects. Now one thing you note is, since that our objects are not hierarchical, we are not going following inheritance. We are going to just make this a vector of game objects. But if you were using inheritance, you would need dynamic allocation of unique pointers to game objects, because you would need to, of course, game object would likely be an abstract class. But since we are just treating this as data, we are going to just loop over all of the objects as is, and then we are going to push back onto the data.draw commands. We are going to construct a new draw command here, and this draw command is going to be constructed with the data of the game object. So the first thing we need is the transformation. For that, we are going to construct a translation and scaling matrix and then multiply them. So we are going to create a translation matrix by using glm translate here. For the matrix, we are going to just start with identity, and then we are going to have to pass to it our object.position here. And we are going to pass 0 for our axis parameter, because this is a 2D game. And we are going to copy this to construct the scaling matrix, but this time we are going to change this to use glm scale, and then for the value we are going to use object.scale. Actually it's object.size, not scale. So we are going to go ahead and we are going to initialize it by 1, by the way, just so all objects have a size of 1 by default. And then we are going to multiply the translation and scaling matrix, and the order does matter here. And after that, we are going to have to do the other things that we need to do in our draw command structure. So the next thing is a texture, but as you can see, our draw command currently lacks a color. We need to add that, and we need to add support for colors as well in our renderer. So we are going to pass our object.texture as well as the object.color here. So now the next thing we need to do is we are going to go under render.cpp, and we need to figure out a way to assign color to our object. Currently you can see we are just assigning a texture and no color, and then we have got our fragment codes. We can just add color by adding another uniform here, which is going to be a vec4 called color, and then we can just multiply this with the sampled color of the texture, so it's going to blend with the texture. And we are going to go ahead and add another location for the color location. And of course, if you need multiple shaders, it might be wise to make a utility shader class, but since we are only doing one, we are going to just do it manually. So we are going to get our color location by using GL get uniform location with the appropriate value. So we are going to use the color name for the uniform, and yeah, after we have got that, then now we are going to go ahead and actually upload the color data into this variable that we have got. So we are going to use the GL uniform for fv command to upload a for vector 4. So we are going to give it the color location 1 for the amount, and then we are going to use glm value pointer to get the value of our command color. And just like that, we have got our color uploaded, and now we should be able to use this. So in order to test that, let's just add a insect constructor. Let's just assign our objects, and we create a single object here. So I'm going to say game object, and this object we can put a bunch of different information, of course. In here we are going to just start by assigning the color and nothing else. So the color, I'm going to set that to yellow color so that we can actually see that it's working. We need to give the blue component 0, and if I go ahead and run this, what you should see is that we get our yellow square at the center of the blue screen, which means that our color is completely working both for the background as well as the object colors. Alright, so now for adding actual behavior to our object, there are a bunch of different things that we can do, but we are going to take a simple hybrid and functional approach. So for example, for adding touch events, I'm going to copy this signature of the touch function, and we are going to add a std function here, and this is going to just have the arguments of the signature of that function that we want, and then we are going to call this on touch. So this means that this is the function that will be called, this is the function callback that will be called whenever an object is clicked. So we are going to go under game.cpp, and we quite simply just need to go ahead and loop over all of our objects and then call the appropriate callback for those that have the callback. So we are going to go ahead and construct a simple loop here. We are going to go over each object, and we are going to go ahead and call the object dot on touch function with the appropriate arguments. We are going to give it the position. The position, of course, is the transform position, and then the type as well. But we are only going to do this if the object on touch method is valid. So the object might not have a function, and in that case we don't want to do that. And we are going to remove the switch statement here. We are not going to do anything in the actual touch event on our own. And if I go under game.h, you can see that we have got this on touch that we can define in the game object like so. So we can go ahead and set on touch is equal to, and we can either leave it at default, which means that it is nothing, or we can actually we are going to make this a lambda function which takes the appropriate arguments. As you can see, this is just really a simple way to add functionality in a simple game. Of course, it won't be ideal for big games, but for now we are just going to use that. And if the type is down, for now we'll just log a message. We'll use the logging.h header. We need to, of course, include that, and then we'll just log a message containing the positions of wherever we hit. So we are going to go ahead and say like that, and then we are going to give it the position.x and as well as the position.y here. And one thing that we still have to do is that we need to only call the touch event if the object is actually clicked. If something else is clicked, we don't want to call the event. So we are going to go ahead and do a bunch of tests, just the standard A/B test. We need to check if our x position is greater than the object's left coordinate, and we are going to just do that for each of the coordinates. And if I go ahead and run this now, as you can see, we have got this here, and if I click on the square, then we get the messages in the logging window. But if I click outside the square, then we get no messages. We only get them when I click on it. So that means that this is working correctly, and our touch input is handling correctly as well as the actual game object architecture that we have got. So anyways guys, this is going to be pretty much it for this video. I'll see you in the next one. Make sure to like and subscribe this as well, and share this video with other people, and bye.